Hey, good afternoon. That's a little loud. So yeah, I'm Robert Koop. This is optimizing manufacturing with driverless AI. So the motivation of this talk is to really give you guys a kind of a high-level look at integrating AI into the business culture of a manufacturing conglomerate, and then to dive into one of our use cases and how we went about selecting a solution and implementing it. So first, a little background. I'm with Stanley Black&Decker, and specifically I run the Artificial Intelligence and Machine Learning group within a unit called the Digital Accelerator. Now the purpose of the Digital Accelerator is to work across all of the business units in Stanley and to infuse advanced technology like robotics, the Internet of Things, augmented and virtual reality, and artificial intelligence into the business and into the business strategy. So when I say that we work across all the business units, it's worth going into a little bit of background about who exactly we are. So odds are when you think of Stanley Black&Decker, you probably think of the store brands and Home Depot and Lowe's and all of the tools we sell. And there's quite a few brands under this umbrella, including, as of last year, Craftsman. So the reality is the tools and storage business makes up just about half of what we do. We have additional divisions in consumer and residential security, in healthcare. So we make the baby low jack product where if you have the wristband on a child, it can't be taken out of the hospital. Fastening solutions. So I think about 3 out of 4 cars on the road have at least one pop rivet or plastic fastener that we produce. Infrastructure products. So these are large demolition machines. And oil and gas pipeline services. So there's really quite a lot going on in Stanley Black&Decker, which poses some unique challenges when it comes to working with all of these brands and companies and injecting technology. Specifically, we've grown by acquisition. So Stanley Black&Decker has been around for 175 years. Many of these brands were purchased as their own company and kind of left to their own devices to run the way that they always have run. So that means we have different information systems, different levels of technological advancement, and in general there's a lot of culture shock when you're trying to inject AI and advanced technology into one business unit versus another. So just a general agenda that we'll talk about is I'll talk about kind of how we're building the culture and advancing the enterprise, a particular problem that we're addressing and the solution that we came to, as well as some lessons learned and general conclusions. So the culture, the question here is, how do you build an AI culture inside a 175-year-old manufacturing company? And it all really starts with top-down support. Thankfully, our CEO, Jim Lurie, is really passionate about artificial intelligence and advanced technology, so we have strong support from the C-level, which really opens a lot of doors. So once those doors are open, we have to drive progress within individual business units. So we engage one of our business units and work with them to find out what problems they have, what they'd like to do, and then typically the next step is to educate. So quite often we will see a business unit, for example, we work with our security company, and they wanted to optimize technician placement with respect to service tickets that technician had to service. However, they didn't really have a clear view of what success was. There were no KPIs, there were no metrics, and nothing in place to serve as a foundation for machine learning. So we had to work with them and educate them about what they needed in order to do AI. And then later we re-engaged with them. So we took a step back and let them work for about 6 months or so. And when we came back, they had KPIs, they had metrics to optimize, and they knew what levers they had to pull to change how the company worked, and it was a really successful engagement. So when it comes to driving progress across the enterprise, the approach we're taking there is to establish an AI Center of Excellence, so specifically the Digital Accelerator and my team within it. And then as we grow as a company and our skills in AI grow, we are embedding resources into the business units. So we're helping the companies themselves hire data scientists and hire AI architects so that our abilities don't, the AI team doesn't serve as a bottleneck anymore, and we enable the businesses themselves to be doing this stuff. So what does it look like running an AI center of excellence? Unfortunately, like a lot of things, it looks a lot like sales. So there's a lot of preparation of materials, PowerPoints, all that fun stuff, because we have to reach out to the business and tell them that we exist. We have to reach out to our numerous business units and show them, here's what we can do, here's what we can't do, here's who to contact, all that good stuff. So it's a lot of relationship building. Without these relationships, people don't know that we're even out there and they don't come to us for help. So another way of doing that is we develop a lot of proof of concepts. Sometimes these are in conjunction with a particular business problem. Other times these are just self-sourced. So we identify perhaps a particular area where we think we could improve something. We develop a POC, and then we go and try and sell it to the business. And this leads to vendor displacement, which is one of the major areas for us to seek project work, where we can find projects that previously external vendors had been contracted for and do the work ourselves. So quite often, as I'm sure all of you are familiar with, AI vendors in the space, it's sometimes hard to tell whether they can deliver the moon and the stars like they say they can, or if they want you to pay them $150K so they can research whether they can deliver the moon and the stars and try and build their POC themselves. So after we do all that, we're currently in the organic growth stage, where now we have some project success under our belt. That's leading to a higher profile, which is leading to more project work. So let's talk about one specific problem. In this case, this project came about because a business unit had engaged a vendor for evaluation. And the Digital Accelerator had an existing relationship with this business unit, so they came to us to evaluate this quote. They wanted us to tell them whether it was a valid proposition or if it was something that we could do ourselves cheaper or some other way. So the problem itself is that there's a complex manufacturing process. And what we have to do is we have to select a combination of parts to manufacture this product. So for example, picture a drill. I can use a variety of motors, a variety of housings, power sources, brushings, bearings. All sorts of parts go into this drill that affect the quality and the lifetime of the product. In this case, the quality inspection itself requires a significant amount of time and labor. So I want to get this right the first time if I can. The current approach we have to this particular problem is that we receive an order from a customer, and that might be for 800 products. It may be a large number. And then an engineer for each product selects parts based on prior experience. So this might be, we have some tools to help so they can look at prior products they've made, prior materials, how they interacted, and that sort of thing. But it really boils down to an educated selection from an engineer based on what they know or what they think. And it requires a lot of experience and a little luck. We then assemble the product. We then destroy the product. And it either passes inspection or we select new parts and try again. So to test the product is very non-trivial. We have to build it first, and then we destructively disassemble it, which is, to put it lightly, we cut the thing in half. We then polish it up, prepare it for measurement, take several measurements under microscope to ensure it's within tolerance and operates properly. And if it passes, we can then mass produce it. If it fails, the whole process begins again. Now, this is a very time-consuming process. On average, it's over an hour just to test one product, one combination rather. There are multiple combinations to test per product, multiple products per order. So all this can add up to times of up to 850 hours just to solve the combinations required for one order. Much less to actually make the parts or make the product after you've done that. So how did we solve this? In considering a solution, we really looked at three major things. First, the cost. Second, the speed. And third, strategic advantage. So ideally, we were looking for things that not only solve this project, but increase our abilities as an enterprise or a team in some way. The different options we considered is we had this external vendor's quote on the table. So we had to consider that. We also looked at just the traditional open source Python stack, so scikit-learn, Python, NumPy, SciPy, all that good stuff. And then we also considered driverless AI. So with the external vendor, there's one major advantage to that. This whole project becomes someone else's problem. There's still project management involved and relationship management there, but they're on the hook for it. I can relax. However, there's a lot of disadvantages. Namely, there's an initial cost of greater than $175K just for the initial system. There's external dependencies, so there's going to be change orders, support, maintenance, hosting, all that sort of stuff. And there's no real strategic advantage here. I've solved this one problem, but I haven't set myself up to better solve any of the future problems. I've just checked this one box and moved on. The open source stack had extensively been investigated, because we're very familiar with this, and this is usually what we use for most projects. The advantages here are the cost of the software. You know, it's hard to beat free. There's no external dependencies aside from the open source community, which I don't think is going anywhere anytime soon. And the strategic advantage is that we improve our skills internally. We get better at doing this, so the next project's easier, and so on and so forth. There's still a number of disadvantages here, and they all revolve around speed. So it takes time to develop the model. It takes time to develop the deployment pipeline. And all of this leads to a KPI that we identified that we're calling, accuracy per development hour. I will make you a promise right now. If you take any model in the world, and give it to my team, they can improve it. It might take a year to go from 85 to 86% accuracy, but we can make it better. So the question there is, what is the ROI per hour when it comes to accuracy of your model solution? And in this particular case for Python, it was not terribly promising. So when we looked at driverless, the advantages mostly revolve around simplicity and speed. It does have a strategic advantage. It gives us a reusable tool to use for our toolkit. So for less than the cost of the vendor, we get a tool that I can use on my next project as well. It simplifies the development and deployment of my model and has a very high accuracy per development hour. It's mostly fire and forget once you've done your data manipulation. I do want to take a second and acknowledge that working with H2O has been a very positive experience. They, as far as vendors go, are very responsive to all of the whims and needs and feature requests and bug requests and all that we've had. So that's been a good thing. The disadvantages here are cost. It's by no means cheap, and there's still an external dependency on a vendor. So once we selected a solution here, here's how it kind of fit into our overall process. We start in the upper left with our work piece, and then we get our production requirements. We feed this into our machine learning system, and our model estimates the test results. So for each combination of materials, and we might have upwards of 50,000 or so, we run this through a model and make a prediction of just a binary, will it or won't it pass the quality inspection. And then we make estimations of several of the different properties that we would reveal during that testing. So reliability, durability, that sort of thing. We then rank order these test results, the combinations, and present them to the engineer, who then builds the product. We run the test, and those results are fed back into our system for batch retraining later. So to develop our solution, first we had to manipulate the data into your observation outcome row format. So we had to do all of the ETL, the data plumbing, the data munging, all of the non-glamorous parts of data science and AI still had to be done. But once we did that, we upload the data into driverless AI, create a model, and export the scoring pipeline relatively easily. We have a supporting tech stack here, which is pretty standard. A web application for a user interface based on Python Flask. This is just a very bare bones, parameters in, model results out sort of format. The model scoring pipeline is hosted via a Thrift server on localhost. So it gives us the ability to host this model on a separate computation machine later if we choose to. And the web backend requests model evaluation. Thrift server scores the combinations, results presented to user. So the overall flow looks like this. The engineer puts in the properties of the product. The web application requests scoring. We run 5 of 10 different models in order to estimate will it pass inspection and what are these properties. They're presented to the web application, which then orders them and presents them to the engineer. So that gives us a very straightforward way of performing this process. So what did we learn during this whole journey? Really, the lessons learned were that speed to solution is critical and that accuracy per development hour is a key metric. One of the overarching requirements of this project is we had about 2 weeks in which we could evaluate this vendor quote and then come back with a thumbs up, thumbs down about engaging that vendor. And during that time, we were able to develop a full proof of concept that outdid the accuracy quoted by the vendor. So we were able to completely replace the need for them in a very quick turnaround. So I would say, in a world where you've got good, fast, and cheap, and you can only pick 2 of them, driverless AI falls about here. It's certainly not cheap, but it is good and it is fast. So the current state of the team and how we are operating, the open source stack is not going anywhere. We're still using Python, Pandas, NumPy, SciPy for data manipulation and rapid prototyping. We've moved over to GPU-based dedicated machines. We used to host AWS instances for GPU, but came close to where we now need 24/7 model execution, so we have our own machines. And driverless AI is used by a portion of the team. It is the preferred tool for rapidly validating project ideas. It's very nice to be able to just take a collection of data, throw it into the tool, and rapidly determine, can I predict Y given X? If I can predict it, it will show me, some results, and if I can't, it will show me that. And in the future, some of the projects we have going on at Stanley that are both underway and planned, in manufacturing, predictive maintenance is a big thing. So we've already got that and we're seeking to improve it. We're also looking at job scheduling. So not only can we do predictive maintenance to increase uptime, we can predict how long it takes to manufacture certain parts and then optimize the order in which we build them. We can also predict how long it takes to change an assembly line from product A to product B and seek to minimize that changeover time by building products in a certain order. We're also working continually with product quality. So this project falls under predictive testing. We're also looking at automated analysis, which tends to be more in the computer vision sort of world. So, what else is there for the future? The AI team within the Digital Accelerator is committed to developing innovative and cutting-edge solutions for Stanley, and we will continue to do so here in the future. So this has just been an example of one of the projects we have going on and our journey through that, but there's certainly many others in the pipeline. Thank you for your attention.